All right, guys, this is going to be the final video before I dive into some examples on I'm sorry, on my math lab. But kind of been jumping around a little bit. Again, I think if we got a good foundation, which I know we did for simple regression, that this stuff is going to be kind of an easy extension of that. But kind of making another jump, we're going to look at what happens when we have a dichotomous predictor. Now, I think in the very first video, we called this a dummy variable as a predictor. Guys, the classic predictor that we can run into that's classified as either this or that, true or false. Zeros and ones is gender, male and female. Dichotomous just means we have a categorical predictor with only two levels, two outcomes, and gender is a classic example of that, as I just stated. Now, and again, these are categorical predictors. And it turns out in multiple regression, if we've got adequate sample size, we can use multiple quantitative and or categorical predictors. Now, this video for the most part is going to start in Blackboard. If you go to data sets, and I'm working at home today. My internet connection is absolutely horrible, but enough of that. So there's a file there that says IQ read gender, and I want to show you what happens with that. Now, I want to open this and just give you an idea of what we got going on here. So we have read, ACT, and gender. And what I would like to do is I would like to take this read score, which if I remember correctly, this read score was taken on the student, I think when they were in the 10th grade. And they took their ACT in either the 11th or the 12th, and their gender was provided at birth. So I would like to use gender and read to predict the student's ACT. And we're going to run into a little caveat here, a little bit of drama, but it'll be okay when I show you how to take care of that. So, guys, let's save this on our desktop just so it makes it easy to get to. Okay, now I'm going to go to Statcrunch, and I'm going to go to the Statcrunch website, and I am going to select a file on my computer. And obviously, I want to do this one, STAT1800 MR dummy. Remember, a dummy predictor doesn't mean it's dumb. It's just. I always thought it was kind of a weird way to call it, but that's the way it is. Now, again, the purpose here is I want to predict ACT from read and gender. All right, so we're going to run into a little bit of problem. I'm going to show you how to take care of that. So if I go regression, multiple regression, I have no problem when I predict or choose my dependent variable, my y, but you can see that my x variable isn't included. And the reason it isn't is Statcrunch doesn't pick up m's and f's. It needs to see zeros and ones. So guys, I need to cancel this. And I need to come in and put zeros and ones. Now the way I code this is males zeros, females ones, or vice versa is irrelevant. But I'm just going to code the males as zeros and females as ones. So now if you had a really large data set, the easiest way to do this is in Excel before you get it into Statcrunch. And you can do some sorting and fill down and drag down, and it makes it really easy to do. This is kind of boring, isn't it? All right, so I got zeros and ones, and I'm going to come up here and call this gen recode. So again, we have the legend here: zeros are males and ones are females, which is extremely important. In fact, it's necessary to be able to interpret our coefficients. So guys, I'm going to run the regression, multiple regression, you see this time everything's going to work perfectly. So I need read, and I want gen recode. I want to run my hypothesis test first. I don't really care about this stuff just yet. So I'm going to go compute. And I always have tunnel vision on my overall model. And my p-value is 0.2167, which is greater than 0.05. So it says, as a set of predictors, read and gender, they don't well predict the ACT score. And you can see that our R squared is only 4.1%. So only 4.1% of the variation in ACT is explained by the variation in read and gender, which tells me that there's 96% that's unexplained. So when I come up and look at my gender, recode, and read, I can see that neither one of these are significant. So really, in terms of predicting ACT, this model just isn't doing the trick. Neither read or gender is telling me much. Now, the purpose of this video, though, was to get into a little bit more than that. I want to interpret the estimates. So I would, for read and for gender. So for read, I would say, controlling for gender. As read score increases 1 unit, the predicted ACT decreases by 0.008 units. That's kind of strange, but it's not significant. We have extremely low sample size. And 0.008 in terms of an ACT score is really pretty irrelevant anyway. I mean, if someone has an ACT of 21.008, and another person has an ACT of 21, well, they're both 21s. So it's pretty irrelevant. In terms of the gender, this would tell us, since females were coded as 1, we would say controlling for the read score, females score about 0.42 higher on the ACT than do males. But neither one is significant. But nevertheless, I'd like to go in and actually just put each individual. So again, I got 4.1%. Let's see if read does anything better than 4.1%. Well, no, not much going on there. 1.8%. In fact, it dropped significantly. And for gen recode, I want to use it as a predictor. And you can see that it is only 2.8%. So guys, as much as I may want this model to work in terms of predicting ACT, let's say that I'm a school administrator and I'd like to be able to predict the students' ACT based on their gender and their read score, I got to come up with something else. This model just doesn't work for me. So, having said all that, I still probably would want to go ahead and check assumptions. I would just rerun and save some things. So I would throw, let's see, I want to throw read and gender in there. And I want to save my predicted values and my residuals. So let's see what the assumptions, if anything's violated. Just because the model's crappy doesn't necessarily mean that the residuals, that the assumptions have been violated. Sometimes there's just nothing there. But I think this kind of turns out kind of interesting to show you that. So predicted values, and then we want to do residuals on the Y. And from this, you can see that we got some stuff going on. We got some, we've kind of got some patterns. And there's not the classic U shape. There's not like a fanning, but I wonder why we have that. Well, the reason we have this is because of the impact of gender. Still not completely convinced that we haven't satisfied the assumptions, so I'd like to go in and put the read score as my X and the residuals as my Y. And I'm fine with that. That's a shotgun blast. But guys, what happens here? This is what I wanted to point out. When I go with gender recode and my Y as residuals, guys, I got a quantitative, residuals are quantitative, but I have a, a categorical predictor. It's either zeros or ones. So that's why I got the weird shape with the first plot where I did the residuals as my Y and my predicted values as my X. So guys, I don't have a problem violating the assumptions here. Just want to point out that that weirdness, strangeness was because of the gender recode. And again, think about it. You know, scatter plots are quantitative. They're plots between two quantitative variables. So when we bring in a categorical variable, you know, we get wacky things like this anyway. So guys, not all models work. Sometimes you write these grants and you put a lot of money and time and effort into it, and then you run your data analysis, a year or two later, and you just found out that what you thought would happen from your grant didn't happen, but it still contributes knowledge to the subject matter. So guys, I think that's it. The next video will be working some problems on my math lab. So take care.